A network-attached storage device can share data out using several different file sharing protocols. One of those is NFS, Network File System, also known as Unix shares. But how do you configure an actual NAS like TrueNAS, for example, to share data out using NFS? And how do you then connect an end device like a computer desktop operating system or a hypervisor like XCP-ng to these NFS file shares? Well, if that's something you're interested in learning about, then stick around and watch this video, because that's what we'll be covering. Now, when it comes to NFS, it's kind of similar to SMB in that we're basically sharing a folder out over the network. That way, multiple users can get access to the same data. They can upload new files, they can create new files, delete files, edit files, and so on. But it's all about shared storage. And that's kind of similar when it comes to hypervisors as well, because they'll need access to shared storage to be able to get access to a virtual machine, for example. Because what we want to be able to take advantage of is much simpler migrations from one node to another. If the actual virtual machine is sitting on a local hard drive, if you want to migrate that virtual machine from one node to another, that takes a long time because all of that data and metadata has to actually be transferred from one computer hard drive to another. Whereas if we're using a NAS, for example, both of these nodes have got access to that same shared folder, and it's just a case of disconnecting one node, then connecting another node, and hey presto, you've actually migrated the actual virtual machine without actually moving the data itself. Much simpler. But at the heart of it all, it's all about user accounts. That's the very first thing we've got to do, is to create a user account. And the one thing to bear in mind with TrueNAS is that we've got to log in as the root user, or at least to the actual web interface here. If we want to share something out, we need something to share in the first place. We either need a folder to share out, or we need a data set to share out, which means we've got to create that. I certainly don't want to share out an entire drive. I want to share out an individual folder or an individual data set. But the problem is, as soon as I create that, it's going to be assigned permissions to the root user, which I don't want. So the very first thing we've got to do is, well, create a user account. Now, TrueNAS is based on a FreeBSD operating system, which means that it's not just user accounts I need to factor in here, but also group accounts. So even though what I'm planning to do is to set up an NFS share where we're actually going to be getting access from XCP-ng hypervisors, technically I only really need a user account to be able to get access to files within that folder. But the problem is, whenever a new file gets created, for example, the system's going to assign permissions to the actual user account. In other words, the actual user account used to actually create the file, the owner, if you will. But it's also going to assign permissions to their primary group, because that's the way the system works. So you've got a user account, and every user account has a primary group. So they have to belong to at least one group. So that way, when the actual system creates this file or folder, it knows who the user is and who the group is to assign permissions to. So in my case, what I need to do is to actually create the group first. So we're going over to accounts, then going over to groups. Then I'll click on add to create a group. Now this is the first group that I'm creating, so it actually gets assigned a group ID of 1000. Now the problem is, I want to be able to get access to this from, say, a Linux machine, for example. And I'm going to have problems if the group ID isn't in alignment on that other computer, based on what I'm using here. And the reason for that is that each computer has its own individual database for users and groups. I mean, we're not using a directory service like LDAP, a shared user account database. Each of them is individual, but we've got to keep them in sync. So for that reason, I don't want to create this group here with a number of 1000, because chances are I've got another computer out there and it's already started creating groups, in which case that number's already used. So for that reason, I'm going to change this to 3000, because I know that for certain that's not getting used anywhere else. So I should be able to go to another computer now and then create an actual group that's got the same name and the same group ID, and then TrueNAS and this other computer are in sync with each other. So now that we've changed the group ID, I'm going to give this a name. It doesn't matter what the naming convention is, it's entirely up to you, but for me, this is all about NFS shares for my XCP-ng hypervisors. So I'm just going to call this group XCP users. Now, When it comes to these options, these first two options, it's all about least privilege, zero trust. This is the security model we're basically working on these days, is that we should only be giving people access to what they need access to. The actual users for this particular group, they don't need access to sudo rights, for example. They don't need to log into the computer and elevate the privilege to where using sudo, for instance. So not surprisingly, that's not enabled by default. We don't want to enable it, because the idea is you only give permissions or rights to people that need access to what they need to. So we're going to leave that as is, but for the same reason, I'm going to disable Samba authentication, because for us, this is all about NFS shares. So they don't need access to Windows shares, SMB shares, Samba, whatever you want to call it. So we're deselecting that option. We also don't want to allow duplicate group IDs, so we'll click on Submit. And then that'll go off and create a new actual user group. Now, one thing to bear in mind is, although we've got this new group here, and it's got a group ID of 3000, it's not going to actually then pick a 3001 for the next group we create. So if I click on Add, you'll see it's gone back to 1000. So it's got its own inbuilt system as to where it starts at, and then it'll increment from there. So in which case, that's just something to bear in mind. Don't assume that the next number is going to be 3000. So if we're going to create another group somewhere down the line, and it's different to this for a different share, for example, we're going to have to bear in mind the fact that we're going to have to change that group ID to something completely different as well. Next thing to do is to create our actual user. So we've gone into the users option there. Click on Add. We'll give it a full name. So I'm just going to call this one XCP user. Click on the username, and that automatically gets populated from the full name. Now, if this had been more than 8 characters, that would have been truncated. And it does warn you if you click on like the question mark about limitations with certain systems and so on. In our case, it doesn't really matter, because that username that we've used here, it's relatively small anyway, so it's not that big of a deal. Password, definitely want to be using something much longer and much more complicated than this, because the only reason I'm doing it like this is the fact that most of the time, even with an actual password that's small, I still end up fat fingering the keyboard or whatever, or typing too quickly, and you end up getting messed up. So if this was like 20 plus characters, I would just never get it done within a video basic. I mean, I could actually set up an actual database manager, for example, for passwords, but there's always the risk I could accidentally copy and paste in a real password, and I don't want to risk that on a video that's out in public. So for that reason, and purely for this video, I'm using relatively weak passwords. But you definitely want to be using something much longer, much more complicated than what I'm doing. User ID. This is our first user, so not surprisingly, this one's starting at 1000, but I do want to change this as well, because again, I'm going to create a user, probably with that same name on another computer, in which case I need to make sure not just the name is the same, but also the user ID. Now, one thing to bear in mind, though, is that the user ID and the group ID do not have to be in alignment. That's not necessary. All I have to do is create a group that's got the same name and group ID that I've created on this NAS server on my Linux computer, for example, and a user account that's got this same username and this same user ID on my Linux computer. That way the two databases are in sync. But the user ID and group ID, they're not relevant to one another. Now, the next thing I want to do is I want to deselect that option to create a new primary group. I mean, it's not surprising that's the default option, because you just literally cannot create a user unless it has a primary group. But I don't want to end up with a group called XCP user, for example. I want to actually use that previous group that I created. So we've deselected that so that we don't create a new one. And I'll just scroll through the list here. Right at the bottom, we'll pick our group out. So now what's going to happen is I'll create an actual user called XCP user that belongs to the group XCP users account. Home directory, not relevant to this. This is all about, for me, it's just XCP-ng hypervisors getting access to a share. So that this particular user doesn't need a home directory. So we're just going to leave it on the default, which is non-existent. In other words, it's not going to create one. In which case the permissions down here we can leave as is because they don't apply. Other options around here we can pretty much leave as is, except for the one at the bottom. We don't want to allow Samba authentication. again, it's a case of this user account, it doesn't need access to Samba shares, in which case we shouldn't be giving it access to them. So we'll click on submit, and that'll go off and create our user. As before, if I go and click on add, the next user is going to end up with a user ID of 1,000. So again, it's not so like clever, if you will, where it says, all right, you actually want to start at a higher range. No, it doesn't work like that. It's got its own internal system. So anyway, we've now got an actual user account and we've got a group account. So the next thing is to actually set up something that we can actually share out in the first place. Now, for a typical file server on NAS, you would usually be creating folders and then sharing folders out. But because of the way we've got TrueNAS set up here, we can take advantage of what are called data sets, and they allow us some extra options over what we would get with a typical folder. So for that reason, I'm going to go over to storage, then I'll go over to pools, and then what I'm going to do is actually create a data set below my main pool here. So this is the pool of data that we've got. All of our hard drives have been pulled together to create this one big giant pool of data. What I don't want to be doing is sharing out the entire pool. It doesn't really make much sense. For one thing, I might want to be able to share certain things out using SMB. Some might be using NFS. Might want, different people to get access to different data, for example, and that would be a lot more complicated if we just share out in the entire pool. So for that reason, we're going to create a completely new data set, which will be kind of like a subfolder of the pool. So we're going to click on the ellipsis here, and we're going to select the option called Add Data Set. And then we're going to give this a name of ISOs. And the reason being is this particular NFS share that we're actually going to set up. I mean, this is just a data set. We'll share it out afterwards through NFS. But this is going to be where I'm going to be storing ISO images, or CD images, if you will, that the hypervisors can take advantage of to then create virtual machines from. And all of the hypervisors I've got will have access to this shared storage. Now, what sets these data sets aside from a folder is all these options. So these are the basic options, but if you click on advanced, there's a lot more. And these come in particularly useful. So for example, we've got compression, for instance. By default, what's happening is anything that's created within that pool is using the LZ4 or LZ4 compression algorithm, but you can change that on a per dataset basis. So you can pick all these different types of algorithms. And that's really useful, for example, if you're going to upload data that's got so like high compression anyway to begin with. There's no point uploading heavily compressed data to a folder, which is then going to result in the NAS trying to compress it even further. It's just going to be a waste of time and probably end up with bigger files in the first place, because it's got to add on that compression header, for example. In which case, we might want a particular folder where we store our heavily compressed files, and we then just disable the compression level on it, because there's just no point trying to compress it again. So that's a useful feature to have. So there's quite a few other options. The only other one I'm going to point out at this stage is the encryption, because this is a one-off choice. Now, what I've done is I've disabled encryption in the pool. The reason being is that I don't really see a benefit to encrypting everything on this NAS. There's going to be a lot of data on the actual NAS that doesn't need encrypting, where there's just no gain. So for example, these ISO files, for example, there's no point doing that because I'm pulling them off the internet. So why would I want to encrypt them? If somebody got access to them, it doesn't matter, they're on the internet anyway. The disadvantage of me encrypting them really is the fact that every time a file gets uploaded, the NAS has to encrypt the file before it can write it to disk, in which case that's adding a bit of latency, it's adding a bit of extra processor time to the actual NAS, so it's going to take longer. It's not as efficient, basically. Same as, it's true in the reverse. When we start to pull files down from the actual NAS, if it's encrypted, the NAS has to unencrypt it, so it slows things down again. So yeah, to me, there's just no point encrypting everything. So I like this option of being able to do things on a per dataset basis. So the way this is set up is that pool doesn't actually encrypt anything anyway. So whenever I create a dataset, it's inheriting this unencryption option. So if I actually want to encrypt a particular data set, I'll have to deselect that option and then start selecting the encryption specifications there. The only thing to bear in mind is this is a one-off. Once you create the pool, you can't go back and change your mind. And it's the same with the data sets. In this case, I'm going with this non-encrypted option for the dataset. And as soon as I click on submit, that's it. I can't go back and change my mind. As you'll see in a minute, I'll click on submit because there's no other options I want to change at this stage. But if I go back to edit options here, even though I go to advanced options, there's nothing in here to allow me to set the encryption. It's just a one-off choice that gets set when the data set gets encrypted. Like I say, it's the same for the pool. You know, I've got this set up without encryption and I can't go back now and change it. If I do change my mind, I'm going to have to create a completely new data set with encryption, copy everything out of this particular ISO's data set into that one, and then I may as well just delete that one because it's no longer relevant anymore. So that's something you've got to bear in mind. You've got to decide whether you want it encrypted or not. In my case, I think it's more efficient to not encrypt everything and only encrypt as and when I need it. But yeah, that's one of the reasons I do like these data sets, is just the fact that, well, one, I can do it all through the GUI. I don't have to drop into the shell and start creating folders, for example. I can just create data sets just by clicking on the ellipses up here and then saying add a data set. So it's a bit easier if you're used to GUIs, but it's also, I'm going to be able to get all these extra options. Anywho, for whatever reason, when it comes to TrueNAS, I have to log in as the root user and that root user's primary group as wheel, which means that this particular data set we've created has actually permissions assigned to root and wheel. And I don't want anybody logging in over the network as root and wheel to be able to get access to them. It doesn't really make sense. At least it's not good, you know, from a security practice. In which case I need to change the permissions on this data set. So I'm clicking on the ellipsis here, and I'm going to edit permissions. So as you can see, the owner is root and the group is wheel. So I want to change those. But rather than just going through the typical permissions that we've got of user, group and other, I'm actually going to take advantage of the ACL manager that we've now got with TrueNAS here. What I'm going to do is I'm just going to go with a preset ACL. Most of the time that's all I need, and I'm just going to select restricted, click on continue, because what that restricted one does is it allows full control for the actual owner, and it allows modify for the group. Now where it's got owner at, it means this user here. Where we've got group at, it means this group here. I mean, you can change these if you like. If you select a user, you then have to tell it which user you want. Now in my case, I'm happy with a specific owner. It's the same as if you want to change the group, you can change it to group and then tell it the group. But there's also a special option for everyone. Now in my case, we've only got these two access list entries. If we scroll down, you can see there's nothing else. But the good thing about it is it allows you to add more entries. For example, you might be able to, you know, want to pick out a specific user who isn't necessarily a member of the group to get permission, for example. So I prefer that over the basic setup, which is just a group, a user, and everybody else. You can get a lot more flexibility through these. But before I commit this, what I've got to do is I've got to change the permissions here. So I'm going to change this one. Well, there's different ways you can do this. For the user, I'm just going to click on the drop-down menu, scroll down here, and then I'll pick XCP user. So there's all those built-in users that you've got in the list. Any new ones you create are right at the bottom. So we'll pick that user out. One thing to bear in mind is if I click on save at the bottom, go down there, it's a save option, nothing's going to happen. The reason being is that you can have such a big impact by doing all these changes to who's the owner, who's the group that's got permissions, that you want you to confirm it. It's a bit confusing, I must admit, when it says apply user. It would have been better if it had, I think, maybe like confirm choices. But, you know, the good thing is you've got the question mark and it does tell you, yeah, that's to confirm the changes. So we've got to tick that box to say, yes, we do want to change the owner to this specific user. So even though we've actually picked a user out that's different to root, unless you tick that box, it's not going to get changed. I also want to change the group. So rather than just, you know, scrolling through that big laundry list of groups, for example, what I can do is just start typing in the name of a group. And what it'll do is it'll parse through the list and give you like a filtered output there. In our case, there's only one group that begins with GRP, in which case that's easier to select and pick out. But again, I've got to tick that box to say apply that specific group. So what's going to happen is it's going to change the permissions for this data set, or if you drop into the shell, it just looks like any folder, to be honest. It's going to change the permissions, and it's going to set XCP user as the owner, and they're going to have full control. It's going to change the group over to be GRP XCP users, and they're going to have modify rights. Oh, mouse has gone a bit strange there. So they've got modify rights. I mean, I can change it to something else if I wanted to. I don't have a specific need. I mean, you can go one step further to give them like full control to change permissions and so on if I wanted to. But that's enough for me for now. I mean, you can even go into changing the basic ACL, the basic type of permissions rather. At the moment, we're set at basic, which is just things like, you know, read access, modify, traverse, and full control. If you go with a more advanced option, there's just a ton of things you can pick, but these are easy enough for me. Finally, we've got an option down here, which is to apply permissions recursively. Now, this is a completely new folder or data set we've set up, so I don't have anything that already exists in there. But if we were making changes to an actual folder that already had files in there and folders, we would want to tick that box and say, actually apply this change to everything. Now, in our case, I don't necessarily need to do that. So I'm just going to click on the Save button, leave that alone at its default setting. So that changes the permissions over. So if I go back into Edit Permissions, you'll see we're now set up with XCP user and group XCP users. If I go into the shell, you can see it from the shell's perspective. So if I have a look at that specific folder, so /mount pool 1, you can see there XCP user who's got read, write, and execute permission, group XCP users, read, write, and execute permission. That's just from its perspective. The ACL manager is a bit more complicated than that. But the key point is that nobody's got, or nobody else, I should say, the other users have got no permissions whatsoever. We've taken all of that away because of that ACL manager. So we've now set up our actual data set. So the next thing to do is to actually share this out using NFS. Now, sharing this actual data set out using NFS is relatively straightforward, but there's just something else I actually need to take into account. So what we're going to do is go over to sharing, and then we'll select Unix Shares NFS. Then we'll click on Add. And I've got to tell TrueNAS what it is we want to share out in the first place. So I'll select this ISOs folder. It's the only one I've got. And you can see it's actually telling us it's got an ACL applied. We can change the description if you want, or put something in there to make it more meaningful. But in my case, you know, the actual folder name is enough for me to understand what it means. We have quite a useful feature here for NFS, which is called all DIRs. And the idea is that typically you'd be on a computer and you'd map to this specific folder, this NFS share that we're setting up. And then you would then have access to, you know, child folders, subfolders within there. So you'd navigate your way through them. Now, if you select this all DIRs option though, you can actually map to actual individual child folders. So you don't necessarily have to map to the parent all the time. You can actually map to ones that are below it, which is quite useful. Now, in my case, I've got ISO images in here, so it doesn't really matter. It's not something that's particularly useful to me, but it's something to bear in mind. Now, this option, though, is quite useful. I'm going to tick that box, and that's just basically suppressing error messages, which could be deemed cosmetic more than anything. Gives you a bit more information there. And the one thing you don't want is a ton of error messages in logs, because when you're troubleshooting, you want to make it as easy as possible for yourself. So logic here is that, well, as long as this works, then it's a case of I'm quite happy to leave that box enabled. If something on the other hand stops working and doesn't go as planned, something breaks, then I would come back and deselect that option. Not surprisingly, we're going to leave that option enabled set, because obviously that decides that particular share is available over the network. It's going to be something that people can connect to. But it's quite useful in the sense that you can actually then disable, you know, sharing on a per folder or per dataset basis. So that's quite useful. That, I mean, you know, for maybe maintenance or something, maybe you want to disable a certain folder from being shared at a certain time of day or something. Definitely useful, that, being able to do it per folder rather than having to do something where you're going to take down the entire NFS service, for example. So yeah, quite like that. So either way, we don't want to be able to get access to it for now, so I'm just going to leave that set as enabled. But what I do want to do is go into these advanced options. Now, I'm not too fussed about the read-only option because I certainly need to be able to upload ISO image files, but these options here are what are of interest to me, because the Zen servers that we've got, they're going to try and connect into this NFS share as the root user and the group wheel. The problem we've got there is, well, for one thing, I've changed the permissions on this data set. They're set up so that XCP user and group XCP users are the ones who've got permissions. So if the hypervisors try and connect in, that doesn't really make any sense. It's a case of we've got a specific user and group that have got access to these. But also I want to kind of like discourage anybody trying to get access through the root and wheel group anyway. So what you can do is you can actually take advantage of these two to actually squash that user root account down to a particular user and group that you want them to be. So what I'm going to do for that reason is I'm going to change this to XCP user and group XCP users. So when the hypervisors actually connect in, they're going to try and connect in using their root account. But what TrueNAS is going to do is just going to give them access based on this user account and group account, in which case they'll be able to get access to the share now. Now, there is an operational benefit to this, in that I now don't have to actually keep a user account and a password on an actual computer, like a hypervisor, for example. The benefit of that is that, let's say somebody were to actually change that user account. Now, if that's been stored on the actual hypervisor, for example, the problem is the password's broken now. It doesn't align with what TrueNAS has got it set up to, in which case the actual hypervisor will stop working. You won't be able to get access to files and folders over NFS anymore. So there is an operational benefit to it, I must admit. In our case, no matter what I do, this then server is going to try and get access as root anyway. As you'll see shortly, it's not giving me an option really to change the actual user. It's just going to connect as root anyway. But it's something to bear in mind with other computer systems that are out there. If they're running 24/7, last thing you need is somebody changing a password, and next thing you've just broken the hypervisors, because these days practically everything's running in virtual environments anyway, so that could have serious repercussions. So we're taking a bit of a business risk out of the equation here, but we're opening up a security risk, because it means that any computer that's out there now that's got access to this share, if it tries to connect as root, it's just going to get access in with these user account credentials anyway, and that's a bit of a security gamble. Something we definitely don't want. So for that reason, we have to take a bit more of a secure approach, where you can see here I've got a NAS, and it's going to have an interface in the 172.16.20 network, same as the hypervisor. So other computers like these ones, for example, they don't have access to that VLAN, in which case they won't be able to get access to that share. The only computers will be the hypervisors. Now, I did use that same subnet in a previous video for SMB shares, but since I'm not planning to do any SMB shares on this network, it's a case of I'm quite happy doing it that way. If I do want to allow anybody access to that, so for example to upload ISO images, what I can do is I can actually provide a connection from the firewall into that specific subnet, for example, and then I can restrict who can get access to it. But it's something to bear in mind, is that we're kind of stuck here in the sense that the hypervisor is going to want to try to use root, so we've got to do something. I mean, if you do these options here, you can't use both these pairs here and these pairs here. These pairs are effectively like an anonymous access, because they refer to all users. If we put a user account and a group account here, then it doesn't matter what account you use to connect, you'll get access, and you'll get access based on whatever user account and group account here. So that's, like I said, it's like equivalent to anonymous access, so that's even a bigger security risk. But these two would trump these two anyway, so you wouldn't sort of like configure these two and these two. So in our case, because the hypervisors are going to try and connect in through root, I'm going to override those. I'm going to squash the root user rights down to XCP user, and the wheel group down to group XCP users. But any other user that now tries to get access, it'll have to log in with a genuine user account and password. What I can do is to tighten things up a bit, is to actually either set up specific network restrictions, in other words, we only allow access from specific subnets, or I can do it on a per IP basis. Now, because it's a lab IP addresses can be changing quite frequently. So in my case, I'm actually just going to set it up for a specific subnet. So for me, it's going to be the 172.16.20 network. I'll just double check that. 172.16.20, yeah. So now what I'm doing is I'm being even more restrictive. So at this stage, nobody, unless you're in that specific subnet, you won't be able to get access into this NFS share. And you can keep adding on here. I mean, you can see by default it's set to a /24 prefix, but we can change that. 24 bits is the prefix length we've got here by default, which for me, you know, it lines up with what I'm using anyway. I can click on the add button and add more subnets as we go along. And I can, as I say, I can do it on a per IP address basis if I want to. But for now, that's pretty much it that I want to do. So we should end up with a share, except we'll see when I click on submit, it says, well, actually, you don't even have the NFS service enabled, in which case I do want to enable that. So I'll click that. So the first time you do start to share anything through NFS, the service isn't enabled. So it gives you that pop-up to actually tell you that you know the service is being enabled. So what we want to do though is, before I finish off, is to go over to services, and I want to make some changes, because you can see there's a lot of services here. They're not enabled by default, so it's a good security practice. But what we've now done, just by setting up that share, is it's actually set up this NFS service, so that's now running, and it's got it set to start automatically. So whenever this TrueNAS server gets rebooted, it'll automatically start up NFS. But I do want to be a bit more security conscious here. So I want to change this bind IP address, because by default it's listening on any interface. So I'm actually going to change that, and I'm only going to listen on that specific 172.16.20 IP address. But there's two reasons for it. One's for security. Another one is the expectation would be this is going to be like a much higher throughput interface. The other interface is more liable to be also like a management interface. There's no point trying to upload files through a what would potentially be like maybe just like a 1 gig interface versus something like this, which would be 10 gig. Also, it's a case of I wouldn't want to overwhelm the management interface. So there's two aspects to it. One is to make sure that the management interface is always around and available and not getting overwhelmed through data transfers. But also it's a security advantage in that unless you're connecting on that specific subnet, you're not going to get access to it anyway. Another thing I want to do is to enable NFS version 4. And that's pretty much about it. I mean, I'm not really at the stage of doing things like Kerberos, for example. And nothing else I can see here that I need to change. Now, if the actual NAS server, or more specifically NFS, starts to get laggy and slow, you can actually add more power to it. At the moment, it's set up for 4 listeners, basically. When you click on the option, it actually tells you about you know, how much it's already set to and how much you can change it to if you want. But here, by default, it's set to 4, and it starts to get slow. You can add more in if you like. But that's not for me, because it's just a test lab anyway. So we'll click on save. And that's made the changes I want. But just to be on the safe side, I'm just going to stop and restart that service just to make sure that they take effect. So it should now be operating with NFS version 4 and only listening on that specific interface. In which case, the next thing to do is to then actually try getting access to it. Now, the reason that I've set up that specific NFS share is to give the hosts access to ISO images. So I'm connecting into my dashboard, if you will, for Zen Orchestra. I've only got one XCP-ng hypervisor, but effectively I want to be able to allow any host access to that NFS share, so that they'll have access to these ISO images that I'll put there. And then I'll then be able to create virtual machines that can use these ISO images to create you know, operating systems. And it's a case of I need to actually connect XCP-ng to the NFS share. And it is relatively straightforward, and since there's not a great deal of information I've got to put in, I just had to factor in that they're going to connect in as the root user though, hence the reason why I've had to squash the actual user account and group account rights down to a specific user that it's already got actually access to that share. So down here I'm coming to the option new, and I'm going to select storage, because this is how we set up access to an NFS share. So the first thing I've got to do is select an actual host. Now I've only got one. I do have an actual pool, but there's only one XCP-ng host, so not surprisingly the pool's got the same name as the host, so I'll pick that. Storage name, well, I've done this before, so I'm just going to select what I've already used, which is ISOs, give it the same description. And then it comes down to the choices of the types. Now, this particular folder or share that we've got is aligned with this NFS ISO. So it's an ISO storage. What we're not doing on this particular one is shared storage for virtual machines, which is what the VDI storage is referring to. With this one, the expectation is that we're just connecting into an ISO storage pool effectively, where we can get access to ISO images. This is one where we're actually going to have a shared storage medium, if you will, where all the hypervisors can get access to, create virtual machines on, and then when we migrate an actual machine from one node to another, we're effectively just disconnecting the node, and then the next node just attaches to that same shared pool. It's much, much easier, much, much quicker than actually storing the virtual machines on the individual nodes themselves. But in this case, like I said, we're more interested in ISO files, so I'm going to select that option. You do have another option, which is SMB, but in this video we're interested in NFS. So select that. You now want to know what the actual server is, so you can put the IP address in, or you can actually get it to do it, DNS resolution. In my case, I'm just going to stick with IP addressing for now. I'm going to change the version over and tell it to use version 4.1, which is the later version that we've got here. And now what I do need to do is click on the question mark here, and what it's going to do is it's gone off to interrogate that actual server, and we've now got a path option here. So we've got a drop down box, and this is the only NFS share that we're seeing, so we'll select that. And you saw the little wheels spinning around there. Now if something went wrong, it would actually pop up an error message, but it hasn't, so that's a good sign. Now you do actually have some options you can put in there, but what I'm not seeing here is an option for changing the user account, for example, to specify a user. But as I say, it's kind of weighing up the security risks versus the operational challenges, and that if we did have a means to put in a user account and password, you've got that problem of, well, if the password changes, all of a sudden your hypervisors don't work anymore. That would be especially a big problem if this was a VDI storage type, because then all of a sudden, literally, the hypervisor wouldn't have access to that share anymore, or in fact, none of the actual hypervisors would, and the entire system would just collapse. So yeah, we are making a bit of a compromise in terms of security, that a computer that can, somebody who's on a computer and has got access to the root account can effectively connect into the actual NAS share just by being a root account, and they'll automatically get access. But we have taken that extra security precaution of isolating the storage subnet away from everything else, so that the idea is only the hypervisors should be able to get access. Anyway, we've selected all our options, all seems tickety-boo. So we'll now just click on the create button there. And that should then connect this hypervisor into the NFS share. So it's done that, but as you can see, there's nothing there. It's a completely new folder, or data set, if you will. So it stands to reason there's nothing there that's available for this to take advantage of. So that's something we need to do, is actually start uploading ISO images. And there's no real option here where I can't like click on a box and say, all right, upload this image from this particular computer I'm connected through. You can do that through something like iSCSI, but I can't do that with XCP-ng, for instance. So the alternative way in which I'm going to do it, long term I should say, would be I would connect the firewall into that specific subnet to allow this specific computer access into that subnet, so that that computer can download ISO images from the internet. It'll then have access to that subnet through the firewall, but the firewall is being very restrictive and only allowing that specific computer or various computers, because the idea is I've got jump servers on here for management of the entire network, all the computers and so on. So that's a security aspect I'm quite happy with, in the sense that yes, that computer doesn't have direct access, but it's very tightly controlled who gets access to the computer and even from where. So the only challenge with that is that these two computers are on different networks. I mean, this NAS, for example, it's sitting in this network here, which is the storage network, but it's also in the infrastructure network. It's got access to the internet through that interface. So if this computer were to try to connect through the firewall, the NAS would see that IP address, and it would then try and connect to it through that specific interface, and the connection would break. You'd have what's called asymmetric traffic. So for that reason, what I would have to do is set up network address translation, so that when the firewall forwards the traffic into the subnet, we would actually have to translate the source IP address of this particular computer. So that way the NAS would respond back to the firewall effectively, and then it keeps everything nicely symmetrical. But this video isn't specifically about setting up firewalls and network translation. That's outside of our scope really here. All we're interested in is setting up NFS, how to get it working on XCP-ng, how to get it configured and so on TrueNAS. So what I'm going to do is I'm cheekily going to get this PC directly connected into that subnet so it's got direct access. That isn't really something you should be doing, so I'm only going to do it as part of the fact that it's a video that I'm doing. My long-term goal really would be to allow that specific computer access, but this is just like a quick fix job so I can show you how to get an actual Linux machine to connect into that NFS share. Now, while I couldn't get access to this NFS share using our XCP user account, what I want to do is actually set up a completely new account, because the idea is that maybe you want to actually set up an NFS share and allow access for multiple users. So in which case we're back on TrueNAS and we're going to create ourselves a new account. So go to accounts, we'll go to users. I'm going to create a completely new user. I'm going to call this one Fred. And I'll put in a password. Again, do make sure you use something a lot stronger and more secure than what I'm using. This is just for demo purposes. Now I definitely need to change this user ID, because when I go to another computer, a Linux computer for instance, that 1000 is probably going to be used anyway. So in which case I'm going to pick this one over at 2000. So the user ID is 2000, the group ID is going to be 3000. So I don't want to create a new primary group for them, but I do want them to belong to this group XCP users instead. So we select that option there. We'll scroll down. Don't want to give them Samba authentication, for instance. They don't need a home directory, so that's pretty much it. So we just create that user. And now what we've got is a different user who should be able to get access to that NFS share. The only thing to bear in mind is they don't have full permission, so they can't change permissions. But what they can do is at least get access to the share. They should be able to create files, delete files, and so on. They just can't change the permissions. So next thing we need to do is to set up an equivalent user account, an actual group account on a Linux computer, so we can test access from there. Now I'm logged into an actual Linux computer which has got direct access to this NAS storage. Now that's not really the long-term plan. I just want to show you how to actually connect to that share through Linux. So the first thing I need to do is to actually create an actual group that lines up with the one that we've got on TrueNAS. So it's going to be sudo add group. Group ID is 3000. And the group's called GRP XCP users. So we've added in our group. Next thing we need to do is to add an actual user. So that user has an ID of 2000. And it's called Fred. So we'll give Fred a password. I don't need to put the details in, but normally you would. I mean, to be honest, if you're setting up lots of users anyway, you'd be scripting this sort of thing. So now I've got our user called Fred. So let's just check Fred's details. There's a bit of lag there. So Fred has a user ID of 2000, but they're actually in an actual group called Fred. So I need to change that. So sudo, that's user mod. So -G to change the group. So the group is GRP XCP users, and we're changing this for Fred. So if you have a look at Fred's details again, you can see he's now actually belonging to that specific group that we want him to be in. So it's a case of his primary group is now the group XCP users. So Fred's now all set up, ready to go. But the thing is, out of the box, we can't actually connect to NFS. So even though this is a Linux computer and NFS is more geared towards Unix computers, the idea is out of the box, we just can't connect direct to it. We can connect to SMB shares, we just can't connect to NFS, which means we need to install some extra software to give Fred access to be able to mount shares and get access to that NFS share so that he can then start uploading ISO files. Now, as usual, the first thing we need to do is to make sure that this computer's up to date. So do a sudo apt update first, and just so I can check that we don't need to update anything first. Okay, so that's fine. The next thing we need to do is to install the software that allows us to actually mount these NFS shares. So for that, we need to install nfs-common. I'll just put in -y so that it doesn't prompt me. Now, once that's done and installed the software, we could manually mount the actual shares to a folder if we wanted to, but I want to automate this. So the idea is I want to take advantage of AutoFS to do that. So we're going to install that next. So sudo apt install AutoFS. And then off I'll go and install that software. Now the good thing about that is it's a case of it'll connect to the actual network share, but it'll all be automated. So with a manual mounting of a drive or folder, if you will, the problem we'll have is whenever you reboot the computer, it'll forget all about it. With AutoFS, this is just totally automated. We just need to set it up once in this case for this specific folder. Every time the computer reboots and that user tries to get access to that folder, it'll map the drive for us. So that's pretty useful, that. So what you need to do is actually edit the master file first, just to tell it what we're going to be doing. So I need to tell it to, well, I'll just put an extra line in there. I need to tell it to use /nfs. This is basically the parent folder. So this is where we're going to be installing all mapped NFS folders, if you will. So now that I've put that, I've actually got to tell it where to interrogate a file for all the information. So I'm going to create a file called auto.nfs. This is going to contain all of the actual mappings for NFS shares. You can basically set up different config files for different file sharing types. And the idea is that any mapping that I put into this config file here is going to basically end up being a child folder of this NFS folder here. So we can have different ones for different protocols. So it's a nice clean way of doing things. I quite like that. So /nfs/etc/auto.nfs. And then we've got to actually configure the file itself, which contains the actual drive mapping details. So this one, we need to give it an actual name for the folder that we're going to map to. We also need to give it the file type, so that's fs type. In our case, it's NFS4. So -fs type equal to NFS4. Then we're going to tell it the drive mapping. So 172.20.30/mount/pool1/ISOs. And I can just keep adding more and more mappings here if I will, if I want to. So this one is going to end up in a child folder of ISOs. So when we want to reference this, we'll be referencing /nfs/ISOs. And then I can have multiple, mappings defined here, all going into different folders. So it's nice, clean and tidy. I must admit, doing it that way. So now that we've done that, I need to make a slight change for NFS because we're using NFS version 4. So that's /etc/default /nfs-common, I think it is, yeah. So what it's got is a setting down here, which basically it's auto-detecting whether Kerberos is getting used. Now, I know I'm not, so just to save myself a bit of time, I'm going to tell it that I'm not. Because we're using NFS version 4, I also need to basically tell it about that. So that's to do with the mapping. So need id mapd equal to yes. So need underscore id mapd equal to yes. So you can see, if you go through these details, it tells you that if you don't specify anything, it does auto detection. That's why I set that one to no. Whereas in this one, I want to tell it yes, we do, because I know it's going to need it. So we made those changes. Now the thing is, I need to restart the service at this stage. because we've made some changes to AutoFS. So we'll do a sudo service for AutoFS, tell it to reload. Then I'm just going to check the status just to make sure that it hasn't thrown any errors. And I'm going to come out of here, and I'm actually going to log into Fred, because Fred has access to this NFS share, whereas that user account David doesn't. So I'm just going to log out. I mean, I could have just switched users, I suppose that's one way. So I'll log in as Fred this time. Just make sure I put the password in properly. Now Fred's a new user, so it's going to prompt us for a series of questions, but I'm just going to jump straight to the terminal just to see if Fred does actually have access to this. So we'll go into the terminal. We do ls-l-nfs/isos. Now it's come back with total 0, so at least at this stage I know that it has connected, because if I do cd/nfs/isos, you can see we're now in an actual directory. The reason it came back with total 0 because there's nothing here. So just to demonstrate that Fred's got access to something, I'm going to do touch cd.iso. So effectively it's just going to create a file called cd.iso. Now if we do an ls-l, the file exists. The only trouble is it looks a bit strange, because the user account, or the owner if you will, is called nobody, and the group that's got permission is just this number. So it looks a bit confusing actually. So the reason that's a problem is to do with some mapping. So what we need to do is fix a mapping on this computer, because if we go over to XCP, well, I need to go over to the actual management computer. Well, actually, incidentally, while we're here on XCP-ng, let's see if we redo a rescan. You can see now it's picking up a disk. So it's picking up an actual disk called cd.iso. So effectively, the actual hypervisor's now got access to this, fake file called cd.iso. I mean, what I'll have to do is actually download an actual image and then copy it. But what I'm just going to show you is if I go to the shell, if we do ls-l /mount/pool/isos, that's pool 1, that's why. Interestingly enough, TrueNAS actually sees this as being a file that was created by Fred, and the group XCP users has got access to it, which is different to what the actual PC that we've got is seeing. It's seeing something completely different, and that's basically a mapping problem that we need to fix. If I can just minimize that and get it out of the way, so you can see we're seeing something different here. So I'm just going to log out of here, because I'm going to have to reboot this computer anyway once I've made this change, and we'll get the actual mapping fixed. So I'll log in as David, because I've got sudo rights on this computer, so I'll be able to make the necessary change on this one, assuming I can put the proper password in. That's the reason why I don't want characters about 20 characters or something. I'll never get that right. Okay, so just wait for this to connect, and then we'll go into the terminal, and I'll make a change that impacts the actual mapping. So if we do sudo nano and it's etc id mapd.conf. So you can see at the moment the domain is basically blocked out. So we actually need to tell it what domain to use, and that's the reason why it's having this problem. So in our case, it is templab.lan. So it's saying here basically this is further down. It tells you about mappings, and it doesn't know. You end up with nobody and no group and so on. It's just confused because of the fact that it's not working correctly when it comes to the domain. So the domain equals templab.lan. So I'll save that. May as well reboot this now. And then once this reboots, we'll log back in as Fred. And this time Fred should actually see the proper permissions. I mean, technically it doesn't really matter in the sense that as far as TrueNAS is concerned, everything's all tickety-boo and working. It's just from the perspective of the user who's creating all these files, it just looks a bit weird. Something seems wrong, but it is actually functional. So it's just literally a mapping. So we'll go back into the terminal again. So if we do cd/nfs/isors, there you go. That's fixed that problem. So we're at the point now where if we go over to our hypervisor, it does see an actual what it thinks is an ISO file, because that's what it's expecting here. This is set up as storage for ISO files for installing CD images into virtual machines and so on. So what I'm going to do is actually download a real one and just double check that this is all working as it should. Now I've downloaded a copy of Debian, so I've got an actual genuine ISO file here. So what I can do is actually copy this across to the actual NFS share. Now I could do it through the terminal, but I can also get access to this share through the actual file explorer here. So I'm just going to select that, select copy. And if I go to other locations, if we go to computer, there's our NFS folder that AutoNFS creates. There's the ISO folders where it's mapping our drive. And if we select paste, it copies across. So I've actually deleted the CD actual file because, well, I don't really want that. That was just a fake file. But just to demonstrate, we can actually get access to this. If we go to Zen Orchestra, if we go to storage, if we go to select our ISOs, get it to rescan, and have a look at the disks. So you can see it can actually see the ISO file. So what I can do now is actually create a new virtual machine using that ISO file. So I'll tell it to create one. I mean, I've only got one XCP-ng server, so I'll get it to pick that one. This is going to be a Debian computer, so I'm using Debian 10. So just call it Deb 10. I'll leave all of those settings as is. I need to get it to pick an ISO file. So you can see it's giving us the option of that ISO file that it knows about on the NFS share. I'll just scroll down. I mean, I'm not really going to create it, but I'll click on create, and then off it goes. So it actually boots up the actual computer, as you can see, automatically by default. So once it's actually up and running, you'll see it'll start to actually give us the actual options. So if I go into the console, you can see it's already literally booted off that ISO file. So, I mean, it's not that difficult to do, really. Setting up the NFS share in TrueNAS is pretty straightforward. To be honest, it's probably easier just using SMB, because you can share a folder out using multiple file sharing protocols. So it might be easier to by all means set up the actual shares for using NFS. You could even use SMB if you want. I'm just really trying to demonstrate how you set up NFS using TrueNAS and how you can then access it, using Linux, because you can actually have computers connecting to an NFS share, for example. So you can have multiple users who get home directories, for example. The process is pretty much the same. You're going to use an NFS share on, say, TrueNAS, and then you're going to give all those computers their own sort of like mappings, if you will, through TrueNAS using something like AutoFS. So that was really the premise behind that, was just to show you how you could use NFS. But I think in reality, it's probably a lot easier when it comes to something like ISO files. Probably just giving them access through like SMB or something, and then you can upload it a lot easier. You don't have to necessarily install the NFS software onto the actual Linux computer, for example. I mean, out of the box, a Windows machine and a Linux machine, they can all get access to an SMB share. So it's much easier for them to get access to that SMB share than it is like an NFS share. It's a lot more complicated, and you've got to weigh it up to think, well, is it really worth it? Kind of makes sense for the hypervisor, because in the case of the hypervisor, you might also want to be able to set up a different type of NFS share. And that's where we're talking about getting access to shared pool of storage to be able to actually install virtual machines on. Now, when it comes to configuring NFS on TrueNAS here to provide shared storage for virtual machines for a hypervisor like XCP-ng, the process is basically the same. So it's a case of I've set up a data set and I've set up a share. So that's now available to XCP-ng. So we'll go over to Xen Orchestra and we'll tell it to create a new storage. And the process is pretty much the same here. There's just one slight change. So we'll tell it which host we want. And we'll give the storage a name, give it a description. Now this is where it kind of branches off from when we were setting it up for ISOs. Here we've got to tell it to use a different storage type. We want to be using this NFS storage type, so it's for virtual disk images versus ISOs. So here we've got NFS ISO, that's what it's trying to distinguish between. You've got NFS, which is for the virtual disk images, so these are for virtual machines, versus NFS ISO, which is for your ISO images. One thing out of interest is the fact that you can't use SMB for that. You can use it for your ISOs, but you can't use it for the VDI storage. I mean, we've also got iSCSI, for example, which I'll cover in another video, but in our case, we want NFS. So that's pretty much it, because now we just need to tell it what server to use. We'll tell it the NFS version we want, and then we click on our magnifying glass, and off it'll go and it'll interrogate the actual server to find out what paths are available. So we'll tell it to use that one. Now it does remember a previous attachment I've had because I've been playing around with storage on this, but in this case I'm just going to click on create, and then that will create this connection to the actual TrueNAS. It basically allows us to then start installing virtual machines in here. So if I go over to new and then select VM, there we go to our pool here. So that's the pool we've got. In my case, I'm just going to pick the Debian image template. I'm just going to call this, say, Deb11. Give it 2 CPUs, 4 gig of memory. Now I do have to tell it what the ISO file is, so I can get that through the ISOs share that we've got. And what I do definitely need to do is change the storage. So by default, it's pointing to local storage, but the intention here is we want to be able to make this virtual machine available to other hypervisors. Now only one hypervisor will be running this virtual machine at any given time. But what it means is that we'll be able to get redundancy. So I'll pick that NFS storage instead, because what it means going forward is that all of the files will be written into this NFS share. And then if this hypervisor were to fall over, another hypervisor, well, you know, as in when I get around to building another one for the pool, it'll be able to run this virtual machine if this hypervisor stopped working. So it gives you really good redundancy. It also means that I'll get much quicker migrations from one hypervisor to another, because the actual underlying data, the real hard drive, for example, that we've got that's going to be built with this operating system resides on shared storage. So we're not transferring data from an actual, you know, local storage on one computer to another. We're just effectively releasing the locks so that the original hypervisor lets go of that virtual machine. The next hypervisor takes control of it. There will be some data transfer, you know, for whatever's actually in volatile memory, but the main data itself, or the data that makes up the operating system, any data stored on the drive, the virtual drive that we've got, it resides on the NAS, so it will never actually move. So that's pretty much it, really. It's a relatively straightforward process. We've just got to remember that we need to create this slightly different storage type when we're actually creating shared storage. And we've got to remember that when we're creating our virtual machines, to actually select that remote storage option. And then after that, off you go and click create. Now, in general, when it comes to using NFS for file storage, one thing to bear in mind is that it can have a bit of a performance bottleneck, especially if you compare it to something like iSCSI, or at least out of the box. So typically what's going on is that NFS is operating in what's called synchronous mode. iSCSI, on the other hand, is operating in asynchronous mode. So NFS is basically prioritizing data integrity over performance. iSCSI, on the other hand, is more inclined to be reliant on the end storage device to guarantee data integrity regardless. So there's a difference going on here, because NFS is basically operating in this synchronous mode where it's sending data across to the NAS, and it's not just waiting for confirmation that the data has been received, it's also waiting for confirmation that the data has been written to disk. In comparison, iSCSI is operating in asynchronous mode, so it's just all it wants to know is, have you received the data? And that's it. So the turnaround is much, much quicker. So that's something you've got to weigh up in terms of using, file storage solutions, as to performance can be quite significantly different. It's something you've got to consider. I mean, if you're going to use NFS, can you afford to lose that data integrity? Because you can actually put NFS into asynchronous mode out of the box, where what's happening in the case of TrueNAS, it's operating in a mode where it's leaving it up to the client to decide whether it's going to be synchronous or asynchronous. So you can actually switch it over if you want. Even if the client actually asks for a synchronous mode, you can more or less force it into an asynchronous mode, in which case you'd run through the normal process like iSCSI, for example, where all the NAS is going to do is it's going to receive the data, tell the client, yep, data's been received, now send the next batch. In the meantime, TrueNAS is then writing that data to disk. The problem that you've got is, if the client thinks that that data is secure and the actual NAS falls over, because at a time when the data hasn't been written to disk, there's always the risk of data being lost. So as an example, let's say you've got a computer and it's got a file in local storage, and the user decides to move it to the NAS. The problem you've got is it's operating in two steps, if you will. It's going to copy the data to the NAS. Now, if the NAS is running this in asynchronous mode, and it's a case of it's just telling the actual client that the data has been received, and send the next batch, what's going to happen is you'll get to the point where all the data is actually being sent across. The client's then going to think, well, that's it, the data is safe, and it'll now go to step 2 and it'll actually delete the file. Now, typically in operating systems these days, if you delete a file, in other words, the user deletes the file, it usually ends up in a recycling bin, so it's recoverable. If you move a file, on the other hand, that deletion doesn't count. It doesn't go into the actual recycling bin. So the problem you've got is that you've sent this data, or you've moved the data, I should say, to the NAS. If your computer thinks that it's all done and dusted and the data is now safely stored on the NAS, it's deleted it, but at that particular moment the NAS then just falls over. Maybe a motherboard failure, processor failure, maybe it's a case of the power's lost, whatever. The NAS hasn't actually got round to writing that data that was in volatile memory to disk, then the data's lost. And if it's been deleted on the client, it's lost for good. There is ways to salvage data off disks, but the sort of things you've got to bear in mind. That's why by default you'll have this data integrity going on, and as a priority over the actual throughput instead. But yeah, it's interesting when you look at the benchmarks in comparison, because you can see significant differences. And it is actually possible to disable that sync option if you want to. So you can actually just basically force like a hypervisor like XCP-ng into asynchronous mode basically. And it'll just carry on sending the data, and in the meantime, we'll get that data written to disk eventually. You just got to weigh up the risks here in terms of, what's your priority here, the data or the performance. But just to give you some sort of comparison here, if I go over to XCP-ng, this virtual machine, for example, if I get this installed, in other words, if I click on that create button, what's going to happen is it'll boot this virtual machine up off the CD image. It will then go through a series of questions, and then once all those questions are answered, it'll install the operating system to this shared storage using NFS. That's going to take me, well, after the next reboot, once the installation part's finished, the actual virtual machine will reboot, and then it'll get the login prompt. So from the point of me clicking that create button, going through all of the questions and so on, and getting that login prompt, takes 34 minutes by default while we're in this synchronous mode. If I switch over to asynchronous mode, it takes 21 minutes. So that's a massive difference in time, 34 minutes versus 21 minutes, just by disabling the write syncs. In other words, going from synchronous to asynchronous effectively. Now, that is doable. It's not something that's recommended, but it is doable. In a training lab, test lab, or something, you might not be concerned. I mean, in my case, I don't actually have any important data as such. I don't have any data to lose. I mean, yes, I'd have to rebuild things or restore them from backup if I had to, and that sort of stuff. But in a production environment, you probably wouldn't be doing that. But in this particular case, what I could do, for example, because this is a data set, I can do it on a per data set basis. So I can just edit the options for this data set, and then I just change the sync option. So out of the box, what's happening is the data set, when you create it, it's inheriting whatever the pool's set to. And by default, that's set to standard. Unless you changed it yourself, it will be set as standard, which means it leaves it to the actual client to decide, do you want asynchronous or synchronous? If we switch to always, it doesn't matter what the client asks, we're running synchronous writes. In other words, we're going to be writing the data to disk, then we'll tell the client. And that's how the hypervisor is operating anyway. On the other hand, if I set it to disabled, then it's a case of it doesn't matter what the hypervisor is going to ask. We're not actually going to sync the writes to the actual hard drive. We're just going to be operating in basically in asynchronous mode. So as far as the hypervisor is concerned, yeah, that data's saved, it's being written to disk basically. But we are operating similar to iSCSI, where we're operating in an asynchronous mode, because the data is being sent over from the hypervisor in this case to the NAS. The NAS signals back to the actual hypervisor to then get on with the next transfer. In the meantime, the NAS is then trying to transfer that data to disk, and it's that process until the actual data is written to disk, will run the risk of actually losing data. So that is one option that you've got. It makes a significant difference. In a production environment, not something recommended. In a training environment, you can weigh it up, training environment, test environment, whatever you want to call it. You can weigh it up, it's entirely up to you. So it is an option. Easy enough to do. It's just a couple of clicks and that's it. And it seriously improves the performance. But there is a more preferred way to do this. Now, we're always going to get higher throughput if we just disable the synchronous writes. But the trouble is, you're at risk of actually losing data. So there is a bit of a halfway house that we can introduce here, which is to effectively cache the writes. So the expectation is that we're going to have mechanical drives in the back end. That pool that we've got where all of our long-term storage is mechanical drives. They can tolerate a lot more writes than say SSDs and NVMe, so they're much better suited for our long-term storage. Give us much better data integrity as a result. But what we can do is we can introduce faster drives as a caching mechanism. So the idea is that the client sends the data to the NAS then sends it to the actual faster drives, and then it tells the client your data is written. And then in the background, what it will do is then transfer that data off the faster drives onto the back-end pool drive. So it's a brief moment where we're keeping it on those on these caching drives, if you will, because it's that turnaround that we're trying to improve. It's the turnaround between the client and the actual NAS itself, and then we can get on in the background with actually storing the actual data. So it does improve the performance, just not as much as disabling the actual write syncs. So to do something like that, I'm in storage and then pools. For this pool that we've got, we need to make an alteration to it. So we'll click on the cog, and then we'll select Add VDevs. Now I've got two drives here that I'm going to use. The idea is that you could have one drive for that. The trouble is, if you receive that data and write it to say disk 7, and that's the only caching that we've got, the problem is if that disk fails before we've got the data off of these onto our pool, well, that's it, you've lost the data anyway. So we'll take a bit of a performance hit again, where we'll actually use two drives to give us the redundancy. So we'll have a pair of redundant cache drives effectively, and then we've got our back-end pool where all the real data is eventually going to get stored. So what we want to do is click on Add VDev here, And this is what we want here, the ZFS log. And as it says, it's an optional write cache. You can add one and you can take it away. You can do it on the fly effectively. It doesn't really make any difference, but we can add this in. And then what we've got to do is, if we scroll further down, you've got this option here for the log vdev. So what we want to do is actually transfer both of these disks here, and that gives us a redundant cache. So again, because it's a mirror, it takes longer to copy it to those two drives than just the one drive effectively, so that the writes are a bit slower, but I'd rather have the redundancy, and that is the recommendation, to have the redundancy. So if we click on the arrow there, we transfer 2 disks. So you can see the estimated raw capacity at the moment is 20 gig because it's set to stripe. So we don't want that. We don't want the risk of the actual, any one of these disks failing would just completely break that cache. So what we want is a mirrored cache. So, I mean, I've got 10 gig, which is probably more than we need, because the idea is we're going to be receiving quite, a reasonable amount of data over the network. But we should be able to get it off these drives onto the back-end drives a lot quicker. All we're really interested in is speeding up that front-end transfer between the client and the NAS. So once we've picked those 2 drives and we've set them to mirror, the actual capacity for the pool itself doesn't change. All we've introduced is this log vdev. As I say, it's called a ZLog or ZLog if you prefer. So we click on the add vdevs. We confirm that, because it says any data. Now, it's just referring to the data on these, not the actual genuine pool that's being lost. It's just these disks, so that's fine. So we'll say, okay, we'll add that in. So it formats those drives and adds them in. So from the pool's perspective, nothing's really changed as such. It's still the same data storage. We've just got this extra caching. So what we should then end up with is, we'll end up with a faster transfer through for NFS. We've still got synchronous writes, but the other suggestion really is to go into your options on that data set, and instead of leaving it set at standard, set it set to always. So then it doesn't really matter. You're always getting that data integrity. Because that's the whole point of it. We want that data integrity over performance anyway. So in which case, do set it to always. Put in your ZLog or ZLog drives, and that's it. It should improve the performance over the normal synchronous writes, but just not as much as it would if you disable the actual sync writes. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.